Assalamualaikum warahmatullahi wabarakatuh. My name is Abdul Muhhey bin Muhammad Musa with a number matric AN170153. First of all, I would like to thank for my panel spending your time for watching my presentation video with a title Building Modeling Information BIM Implementation for Energy Consumption Analysis Block A UTHM Campus Pago Case Study. And again, I would like to thank you to my supervisor Encik Muhammad Syafiq Shazwan bin Mustafa for his guidance, ideas and solving problems with giving a feedback regarding to my final project. And for my abstract, as we know, in common use of building information modeling, which carry out organized process and activity to product a better contribute in construction project, and then Revit was used as analysis tools through the design process to refine the building design and make decision about energy performance. This project to propose a building resistant material which is on Block A UTHM Pago campus, used through the provisions of new information, tools and visual to carry out. We determine and analyze the selected 3D building models. With a latest utilizes Autodesk Revit to take out the building performance analysis BPA using a Green Building Studio GBS cloud-based and to foresee its energy performance, including the top of building material and enduring impacts. This analysis can gauge the cost, cooling and heating elements and electrical use of a building. With a single and current workstation, an engineer can do the total interpretation of the structure easily. As the result, the case study of Revit and GBS concept to gaining the information properly in the form of visualization, through which its use can facilitate a better information management and detailing energy consumption through the illustration chart by analyzing, determine and retrieve the information, as well making optimized decision with provision of reliable, accurate information. We consider building design, material and settings. Energy analysis in a BIM help in determining of a proper location for energy consumption and help in propose accurate and efficient simulation input for energy analysis. Building information modeling BIM comprised of advanced visualize of physical and practical quality of the structure. It fills in as a mutual information as set for data about and office shaping and dependable reason for choices during its life cycle for initiation forward. The model maps are roughly near the genuine structure. To close the model in is to the real world, more important the opportunity to make a high performance building. The integration of BIM and energy assessment tools have a significant contribution for selecting material and component with lower impact on the total energy consumption of buildings. In most of the cases, these elements are selecting taking into account only functional, financial and technical condition. Professional architects and engineers are more concerned about the sustainability and energy performance of proposed buildings. Energy consumption of building at a conceptual design stage is very helpful for engineer when selecting the design alternative that lead to a more energy efficient facilities. For my literature review, BIM is an intelligent model-based process that connects architectural, constructional, and engineering professionals so they can better design, build, and operate buildings. BIM cooperates with architects, engineers, and contractors on redesigned back model, giving everyone the visualization of the project and help them work more better than usual. And for the assessment tool for energy analysis, I take a two software, which is Autodesk Revit Architectural Version Student and Autodesk Green Building Studio GBS. Autodesk Revit Architecture. The tools and features that make up Revit Architectural are specifically designed to support building information modeling workflow. Revit was intended to allow architects and other buildings professionals to design and document a building by creating a parametric three-dimensional model that include both the geometry and non-geometry design and construction information. Autodesk Green Building Studio GBS, a flexible online cloud-based service that allows to run building performance simulations to optimize energy efficiency and work toward carbon neutrality at the beginning of the design process. Green Building Studio helps expand the ability to design high-performance buildings at a fraction of the time and cost of conventional methods. Next is for my methodology. I will go to building selection, which is I will take a building Block A UTHM Campus Pago. And for the next step is collection of drawing and information about the building to be studied. In this section, there are three elements which the building are needed to analyze. The first is architecture drawing and structural drawing and MEP for electrical drawing. And the third step is a 3D model using Autodesk Revit, which is I go a 3D view in a Revit software to get it to build up and setting it properly. And then I go to a location setting, which is a Pago. Then for energy setting, I created the partition for selecting the ground plane to get the whole building floor area. And then after that, I go to create a building analytical model, which is a next step for energy building analyzing. And if it's yes, I will export the Revit drawing into a XML files. And if it a no, and we must do back to the 3D model using Autodesk Revit software. After export, I will go to a GBS website, which is a web cloud based, and upload the file of XML files to run the simulation to get the result. And then after that, it will show the data building performance for annually and monthly, cover for a cost, electrical and fuel. That's for annual. And for monthly data, it will show only a cost and energy that cover up into a total energy, electricity and fuel, which is a natural gas. For result and discussion, but firstly, I would like to present for annual data, which is a cost that cover up for total all of the energy, which is space cooling, one of the major contributes, which is it takes 51% from the whole energy total. And for energy, it also a space cooling that contribute to the building use the energy which is 45% from all of the total energy. And next is for energy use intensity. Space cooling also one of the contribute usage that take 45% of energy. For monthly data, the cost for each month take probably 50%, for 51% until 50% usage each month that contribute to space cooling, which is one of the major usage. And then for monthly energy, it's also space cooling contribute for 44% until 46% for each month that take a major usage. And for conclusion, this project demonstrates the use of the energy analysis under the BEAM frameworks, where there is a reduction in need of the re-entering information in a compatible system. This is an advantage not only in saving times, but also in reducing copy errors and emission of important data. The computational requirement is also not overwhelming in today's standard. With a single and modern workstation, an engineer can carry out the complete analysis of small building with easy. That's all for me. I hope you enjoyed the video.